Okay, good morning, or good afternoon, depending on whatever class you're in. As you guys have already noticed, um, I'm not in school today. So I want to start off before this video start. I really hope that with the little time that we know Miss Perez, that we still can respect me in my classroom enough to make sure that we respect our substitute or whatever teacher is sitting in for me. Thank you so much. Okay, so with that being said, by the time this start, we should already have everything we need. I'm gonna get straight to the point. I'm gonna skip all the fun part about it. You need your pencil, you need your notebook, and you need our packet. We are still continuing on with everything that we started yesterday, and we are still taking notes today. So if you are not ready, please pause me. I'll wait. Okay, so my guess is now we got it. Okay, cool. So continue on with our notes. Yesterday we did scale copy, right? And this is how our book should be. Now, as we doing these notes, it's up to you if you want to continue on this page. If you have room, like I have room down here, so I could have continued, but I didn't want to. But if you do, you can. It's up to you if you want one page per thing. With this, I just put it on the back of it. And today we are doing corresponding parts. So at the top of your paper, please write corresponding parts. Y'all see my bait emoji? Working from home today. Okay, so today we have two goals. One goal, I can describe what the scale factor has to do with the figure in the scale copy. Our second goal is in a pair of figures, I can identify corresponding parts, corresponding line segments, and corresponding angles. First thing first, before we get started, can anybody tell me what's a scale copy? I'm going to actually give you a minute for someone to say out loud the definition of a scale copy. Hey Siri, give me a 60-second timer.
1 minute, starting now.
My Siri British, but I know y'all know that. So in this time, when I'm listening for, or what class is listening for, is someone to say in your own words or read your definition, what is a scale copy? So in that time, I really hope somebody says somewhere along the lines that a scale copy is a copy of the original. It just can be scaled up or scaled down. It also could be the same size, but don't worry about that. We'll get down there later. So somewhere around that definition. Okay. And then the next question I have, what does the word corresponding mean? We went over corresponding enough yesterday or inch yesterday where someone should be able to tell me, what does the word corresponding mean? Hey Siri, give me 30 seconds.
30 seconds, counting down.
Good job, baby. I really hope somebody says something and I'm not just sitting up here seeming all crazy. But anywho, I really hope that somewhere in a corresponding world, someone mentioned that corresponding is the exact same position on another image. So the exact same position on another image. Okay. All right. So let's get into it. We're going to skip our notice and wonder just for the day. I really like notice and wonder, and I know you would like it too down the line, but we're going to skip it for today, obviously, because I'm not there. So we can't do a proper notice and wonder. So from here, I want us to start writing down a definition of a corresponding parts. So you have options. If you look on the backboard, you will see that I already put the definition of corresponding parts. It should read somewhere as a part which occurred at the same related position on another figure. I don't know if it say those quote words. So you can choose to write that definition down like I have. That's my definition I put on. Or you can put whatever you need to put down on your paper for you to understand what does corresponding parts means. What are corresponding parts? So it can be as simple as corresponding part is the same position on another figure, which is true. Okay, so now getting into our assignment, and we starting off on page 4. With number 1, we looking at these figures. We have our original circle with the X through it. We had copy number 1 and copy number 2. So number 1 should say, complete this table to show corresponding parts in the 3 figures. So before we do this, let's look at the example they gave us. This gave us the point K in the original figure. Okay, let's first find the point K. So if I look in the original figure, the point K is on the top left side. There we go. It's a point K in the original figure, A in the copy number 1, so I'm going to circle A, and U in copy number 2 are all corresponding angles. So in the original one, we got this K. Well, in the same position on this angle will be A, and the exact same position on this one will be U. These are all corresponding angles. I'm sorry, I take that back. These are all corresponding points. These are corresponding points. All right, so let's do that first one. The first one on your page say corresponding P. Well, what point would correspond with point P in the original? By now, my guess is somebody said, well, point F and copy number 1, point F. That's true. And then what about copy number 2? By now, somebody would have said point Z, point Z. So I would have wrote that down. So point P correspond with point F in copy number 1 and point Z in copy number 2. Okay. So then we start talking about line segments, and down the line they start asking about angles. This still makes sense. A line segment, or in this case they should say the word segment, but a segment is a line from one point to another. They are giving us line segment LM. So I'm going to take my pencil and I'm going to draw a line through line segment LM, which is right there. So what segment will correspond with that exact same line? Well, in copy number 1, it looks like segment BC. That makes sense? LM is over here. BC is over here. You let me know what correspond in copy number 2. Okay. And then let's skip down to that fifth one on the table where it say angle KLM. Okay. Let's look at the angle KLM. Because when we talk about an angle, we need 3 of them. So on the original, I'm going to go and I'm going to mark angle K, L, and M. That's that guy in the corner. Well, what correspond with this guy? Well, this guy in the corner. And what is that guy in the corner in copy number 1? By now, someone would have said angle ABC. And I agree. So, what I want you to do is, I want you to finish out part number 1. I'm sorry, question number 1. And then I want you to go down and do question number 2, which is asking which one of these copies are scale copies of the original and why. Let's give you 3 minutes. Hey Siri, can I get a 3-minute timer?
3 minutes, starting now.
Two minutes left. Remember, in this time, what you are doing is you're finishing up number 1 because we already started it off. And then you are also doing number 2 down here, which number 2 is just asking which one of these copies between copy 1 and copy 2 are actual real scale copies of the original. Now remember, a scale copy, don't get fooled. Give me about 30 more seconds. And then we're going to go over a few of them in number 1. And then I will be looking for the answer for number 2. I'm very animated. I really hope you guys are joining me in this animated world of mine. And it's like, I'm not just sitting up here talking to myself and somebody. Ladies, please don't let me talk to myself. Like, I'm looking at you over there in the back. No, I don't know who I'm looking at. I'm just talking. Okay. So with that being said, we should have completed number one and number two. Um, let's do a few in this. Let's finish this out. Let's finish out the second one. So we was doing line segment LM, and we said in copy one that correspond with line segment BC. What about copy number two? By now, I would have got the answer that it correspond with line segment. Oh, can't see. VW. Okay. Um, let's skip and do the fourth one with the points. It started with saying, well, in copy number two, point W. So let me go find point W. What will correspond with point W in copy number one? Point C. I agree. And then what will correspond with point W in the original? All right, point M. Got it. Perfect. Get it, got it good. All right. So hopefully we got this. If you didn't get this and I'm just over here totally talking over everybody's head, no worries. I'll be back and I will make sure we go over this. I just wanted y'all to finish the lesson today. Number two. Number two said which copy was actually a scale copy of the original. Hopefully somebody raised their hand and said copy number one. If you look at it, copy number one is a scale copy of the original. What's the difference? It's just smaller. I agree. What's wrong with copy number two? Hopefully somebody say like it's kind of stretched out. And because it's stretched out, it's no longer a true copy. Good job. I agree. Okay, so looking at question number 3 and 4. Number 3 and 4 is asking for tracing paper. I'm sorry. I did not put none out. So I guess we gotta use our imagination. That was from SpongeBob. Let's move past that. Number 3 say use tracing paper to compare angle KLM with its corresponding angle in copy number 1 and copy number 2. Okay, let's not use tracing paper. Let's we got imagination. So we already got KLM ready. And from our table, we already know that its corresponding side was ABC and UVW. All right, so let's see. In our imagination, if we look at those two, well, if you compare the original to copy number 1 of the angles, they look the same. You would think they was the same amount. And then if you compare the original to copy number 2, it's like it's getting smaller. Like copy number 2 angle is smaller than the original. And yes, that's exactly what we would have found out with tracing paper. Number 4 say do the exact same thing, but we use an angle NOP. NOP, that's down here. NOP. And the angles that correspond with NOP would be DEF, which we already figured out on our table, and X, Y, and Z. Cool. We can still use our imagination. And if we use our imagination, what will we see? Well, the original and copy number 1, those angles look very similar to each other. You would, if I had to guesstimate them, I would say they was right on point, the exact same angle. But in copy number 2, that angle is way larger. Angle XYZ is larger than NOP. That makes sense. So what can we tell from this? Well, we already said that copy number one was a scale copy and copy number two was not. So now this introduces us that even if we don't have numbers off the angles, we can still tell. So if it's a true copy, it will still have all the same angles. If it's not, the angles will be different. I hope I didn't lose no one because I'm moving on. Page 5. Page 5. We got practice problem number 2 and 3. All right. Practice problem number 2 says figure B is a scale copy of figure A. Select all the statements that must be true. Figure B is a copy of figure A. Select all the statements that must be true. Let me give you 30 seconds to do this problem. Hey Siri, give me a 30-second timer.
30 seconds. Counting down.
All right, let's look at this. What must be true? A says figure B is larger than figure A. Do that have to be true? No, because it always can be smaller. We literally just seen one. The copy was smaller than the original, so A don't have to be true. So put a line through it. B says figure B has the same number of edges as figure A. Do that have to be true? Yes, that has to be true. Because in order for it to be a scale copy, it has to look the exact same. It just can be smaller or larger or the same size, but it has to have all the same composition, the same characteristics. So B is true. C say figure B has the same perimeter as figure A. Well, the perimeter is when you're going around an edge, and we know that's not true because if something is larger, it will have a larger perimeter. If something is smaller, it will have a smaller perimeter. So C is a no. D, figure B has the same number of angles as figure A. Well, we can go back over here and look at this. This was the original. This was our scale copy. It definitely had the same amount of angles, and it had to in order for it to be a copy. So D is with it. E say figure B has angles with the same measurements as figure A. Well, that's what this whole lesson was about, was the fact that the copies have to have the same angles. They have to have the same measurements. So figure E also goes. So with that, we figure out that B must be true, D must be true, and E must be true. Number 3, it says polygon B is a scale copy of polygon A. We got these two polygons at the bottom. Okay. What is the scale factor of polygon A to polygon B? Scale factor? We didn't even say that word today. What does scale factor mean? Oh, wait, but we did use it yesterday, right? Okay, so I'm going to go take one day back in my notes and figure out that scale factor. And from yesterday, remember back with our F, in some classes we did a scale factor of 2, and in other classes we did a scale factor of 4. But if our figures was 2, 4, and 1. With a scale factor of 2, our figures moved up to 4, 8, and 2. So we said that scale factor was just that middleman. It was the number that we was multiplying our original by. Okay? So what's the scale factor? Well, first I need to line it up to make sure I'm matching the right corresponding sides to each other. Well, in this A, they gave us 2.5. What side in B correspond with the 2.5, the top of A? So what will correspond with the top of this? Well, right here. So the 5. Okay. So in A, I got 2.5, and in B, I got 5. 2.5 times what will give me 5? Remember, I got 5 calculators out in random spots. If you're on a table with a calculator, please feel free to use it. Okay, so by now, somebody should have said, well, 2. 2. I know 2.5 times 2 is 5. What's my scale factor? My scale factor is 2. All right, that answer A. So B says, find the missing length of each side. Okay, we can do that. In this first one, A, it had this 1.5 over here. We already just said our scale factor was 2, and we know as a scale factor, we got to multiply this angle to get to this one. So 1.5 times 2 is by now, I'm really hoping somebody yelled out 3. 1.5. 1.5 times 2 is 3. All right, and then we had that other side, which was 2.5 again, but we already said 2.5 times 2 was 5. So this missing side should also be 5. So from there, we labeled those sizes. C say, determine the measurement of each angle and mark it. Okay, so in A, this angle up here in B is 53. So what must this angle be? Well, today our whole lesson was saying that if it's a scale copy, it must have the exact same angles. So that must also be 53. And then the bottom angle in B is 82. So what must the bottom angle in A be? 82. 82. All right, with that, we almost done. One last thing I want to do before I release you. In your book, underneath corresponding parts, put the word scale factor. Scale factor. Okay. All right. What's the scale factor? We just went over this, but in your own words, can somebody tell me what's the scale factor? In your own words, what's the scale factor? Hey Siri, give me 60 seconds.
1 minute, starting now.
In this time, I am listening, or we're listening, for someone to say in your own words what a scale factor is. Also, we finna write this definition down. So if someone already said it, or if you already have an idea of what you want to write down, start writing. Feel free to start writing that down for me. All right. So the true definition of a scale factor is saying it is something that's multiplied. The original number multiplied by the scale factor will give you the scale copy. So I think that's a really good definition to put down. So that's what I'm going to put down. I'm going to say our original figure multiplied by the scale factor will give me a scale copy. So it's like that middleman. That makes sense, right? You have an input, you have the rule, and you have the output. I haven't told you that. No worries, I'll tell you tomorrow. So let's write that. Original figure multiplied by the scale factor, and underline the word scale factor for me, will give me a scale copy. Okay, so in your book, in your notes, if you have the definition of a corresponding part and you have the definition of a scale factor, that's all I have for you today. We're not going to have a cool down today, only because I'm not there to collect it anyway. And that's class. Please, as you get up to exit, make sure that you bring tomorrow. You still bring your notebook because we're starting Wednesday morning with this. Hopefully, I am back by then. You still need your notebook tomorrow. And you, as always, you need a pencil. Have a wonderful day. Please, as you leave the classroom, wash your hands, okay? Wash your hands, use hand sanitizer, do what you got to do to stay safe. Guys, have a wonderful day. See you tomorrow.